So the first thing we'll do is load the ARB file on the SMBV. You can also use an SMU or an SMJ, but either anything that will play an ARB file will be fine. I have it on a memory stick. The file is called FSVR TX Transient. So we're going to load that up, run it. It's about a 2-second long ARB file that has this repeating key on and key off of the transmitter. I'm going to set the power level to 0 and turn the RF on, and at this point we're really finished with the SMBV, so I'll move it out of the way. So now let's go center up on this signal, 1 gigahertz, and I'm going to use for this measurement and all my measurements a 200 kilohertz span or demod bandwidth, as whatever the case. I'm going to set the amplitude up to 0 to match the signal, and now we can see that I have this repeating key on, key off. You can see a little bit of frequency wiggling going on here, but it's hard from this view to see much of any detail of what's going on in the signal. And one thing we can do in standard spectrum analyzer mode is go to 0 span, which I'll do that real quickly here. I'm going to set my sweep time to 500 milliseconds, and I'm going to set a trigger for IF power and a trigger offset of minus 50 milliseconds so we can see the beginning of the burst. Okay, so there we see the rising edge of the burst. We can see that it has a nice level power across the on time of the burst, and then here's where it turns off. Now from this view I can see those things. I can see the output power is nice and level. It should be. This is an FM transmitter. And then we can also use markers and measure that pulse width. If we do, we'd see it's about 450 milliseconds. But I can't see any frequency dynamics in this view at all. So if there's any settling time going on or any frequency error, it's invisible to me in 0 span. So that's where we go to the next step. We'll use K7, the analog demod option. And this is an underappreciated option that should be used and sold more often. I'm going to show here what that signal's doing during its on time. So I'm going to set the demod bandwidth down to 200 kilohertz. I'm going to set the measurement time 500 milliseconds again. I'm going to set the deviation per division, the vertical scale for the FM demodulator, to 10 kilohertz per division. And then I need to set my trigger again to IF power with a trigger offset. I'm just going to use 2 milliseconds in this case because I don't want to cover up my annotation out here. So now I see the on part of the burst is this part right here. When the burst is off, the FM demod just produces this large noise band. You see a little bit at the beginning and a lot here at the end. But the on part of the burst, and this would be the same timing that I'd measure in 0 span, is here. But what I also see is this frequency offset. So there's settling. When the power turns on, the frequency is roughly 16 kilohertz low, high, and then it goes down to about 6 kilohertz low, and then finally settles out. I also have a small frequency glitch here. Don't know what that is, but it's in the signal. And then we finally get to these tones, which the walkie-talkie produces as signaling tones. That's just simple audio right there. And this tells me a little bit more about the signal, but it doesn't tell me everything. Specifically, what goes on out in this area and before the burst turns on. There's actually some interesting things that are happening, and we can only see those when we go into our real-time mode, which we'll do next. Now we're going to set this up. We're going to set up a spectrogram. Now the spectrogram, if you've never seen one before, is a time history of spectrums. So the x-axis is still frequency, but now the y-axis is time, and the amplitude is encoded in color per this little color bar at the top here. So the more red the trace is, the more power there is in it. So what we're going to do now is set up a span of 200 kilohertz, just like we did in the other measurements. And for this signal, I'm going to set up a measurement time of 1.3 milliseconds. That's an odd number, but it works well for the duration of this signal. The next thing we want to do is set up triggering. This is a little different in real-time mode. Instead of IF power trigger, we're going to use frequency mask trigger. What that means is as soon as a signal comes up inside a mask that I create, that generates a trigger event. Now what we measure is determined by these two buttons, before the trigger and after the trigger. Pre-trigger is 60 milliseconds, we'll leave that alone. Post-trigger, I want to make sure I see the burst turn off, so I want to set 500 milliseconds of post-trigger time. Now what happens is, once I set up the frequency mask, which I'll do here, we push the new mask button. This is the default mask the FSVR always sets up. How this works is anytime the signal goes into the red area, it generates a trigger event. In our setup, we're going to use this default mask because it's fine. As soon as the signal turns on, it goes into that red area. As soon as the signal enters that, we're going to know what happened 60 milliseconds before and 500 milliseconds after. So we close this, and there it is. The mask became active immediately. I had a trigger event down here where the power turned on, so I see before that and I see 500 milliseconds after that is written into my memory. And this is why I set up 1.3 milliseconds, because it fits on the screen nicely. There's nothing magic about that number. But now look what we can see. Here's where the burst is on in this area that has kind of the greenish background, and we can see that frequency settling that happens that we saw in K7, where it's 16 kilohertz high, then it goes 6 kilohertz low, settles out. We have our little 3 kilohertz glitch here, and then the audio tones. But look what else we can see. This is the new stuff. Before the burst turned on, before the power amp in that walkie-talkie turned on, we can see that the VCO was settling. It swung from way high over here to about 90 kilohertz low, settled down almost dead on frequency, and then when the power amp kicked on, it settled some more. And then when the walkie-talkie is keyed off, you can see the power goes down obviously, but then there's more settling or wiggling by this VCO. It's kind of interesting behavior. Now there's a couple more things we want to show here. One is this is a nice feature in the FSVR. If I want to optimize my color range, you see all this blue clutter that comes from the noise. Let's double click in this color bar up here, and now I have a histogram showing all the different power levels that are in the picture, and I have these sliders that I can use to change where is my lowest color. Well, I don't want to waste color in this noise area that's down in this bump. So I'm just going to go right into this little valley, because everything above that is actually part of my signal. Now when I do that, I get much better contrast down here to see what this signal is doing at these low amplitude levels. So that's one nice feature. Normally adjusting color scale on a spectrogram is a kind of painful iterative experience, and this is much better. So next thing we want to do is set up a dual screen. So I click on that button down there, click on the top because I want that now to be a real-time spectrum. So this is now going to show me, if you see down here on the bottom, there are these two little white markers. They identify a horizontal slice of the spectrogram. Every horizontal slice represents one spectrum up here. So what I'm going to do now, click back on the bottom so the spectrogram's active, go to the sweep key, select frame is the button we're going to use. Now on the analyzer you'd actually turn the knob, but since I'm doing this with a mouse, I'm going to use the wheel on my mouse, and I'm going to scroll back in time a little bit before a trigger event. Now these little, you can see these little horizontal markers here. Every slice out of the spectrogram is showing up above. So now I'm eventually going to see this signal swinging in from the high side. There it is. It swings low. There it's about 90 kilohertz low. Swings back overshoots on the high side, settles down, and then we'll see the power jump up when the power amp kicks on. That's what defined my trigger point. That's when the signal entered this red area that the mask we defined. So now we can see we're about that 16 kilohertz above when the power turns on, just like we saw in K7. Now we can go down and see that we're 6 kilohertz low, and we settle out. But look what else we can see that we couldn't see before. Not just the frequency of the settling, but these sidebands. I've seen other transmitters where the sidebands are much worse than that and got a lot more attention from the customer. Alright, so now we can scroll up through time. There's that little 3 kilohertz glitch that we saw in K7. There's where the audio tones turn on. This is where I dekeyed the transmitter, the power amp turns off, but then look what also happens. That VCO does some more frequency wiggling. And that's what the FSVR brings to the table, is this real-time mode where we can record a signal or view it in real time and see this dynamic amplitude and frequency behavior that is really impossible to see in any other way. If you